Okay, so let's begin today's experiment, which is laboratory 4, which is the determination of the chemical formula of copper gluconate. So first things first, we're going to get on our safety goggles and our gloves. And we're going to get out our portable balance, which you see in front of you. So let me get a pair of gloves on because I don't want to expose myself to any chemical residue. Okay, so you're going to tear your scale and it should show 0, 0. Then what you're going to do is you're going to place a weigh boat on the scale. And then we're going to tear the scale. So we're going to place a weigh boat on the scale. And then we're going to tear the scale. So before looking at our weigh boat, we see a value of 2.7. That is the mass of our empty weigh boat. Now we're going to tear our weigh boat. And now we're going to record the mass again. So it should see 0.0 if everything is done correctly and it's fully teared. Now, what we're going to do is we're going to get out our bag of copper gluconate and we are going to weigh 1.4 grams. So we have our spatula ready to go and we're going to carefully weigh out and transfer 1.4 grams of copper gluconate, keeping in mind that this should be done above your weigh boat. So all of your transfers, in order to minimize spills, should be done above your weigh boat. There's about 2 grams in your bag, so you're going to need almost the entire contents of your bag. You want to keep your transfers as close to still have a long ways to go. So we'll continue this transfer process and we're going to try to get almost the entire contents of the bag transferred. Try to weigh without keeping your face as far as possible from the mixture just to avoid breathing in the dust. And again, you should be performing your experiment in a clear, well-ventilated area away from any other people or objects. So we'll continue the weighing process. Okay, and I have a little bit extra, so I'm going to transfer that material to a separate weigh boat. And then we'll reseal our bag for later. Now, in the event any spill occurs, we're going to clean up our area. So let's clean up our area briefly, and then we'll resume momentarily. Okay, so we wiped down our area, and we have finished weighing out our desired 1.4 grams of the copper gluconate. So let's take a look and let's record the mass of copper gluconate in our weigh boat on the balance. And then we will continue on with this experiment. So once again, here is the mass of our copper gluconate. Okay, so now we're going to set our copper gluconate to the side and move our balance to the side. Just going to wipe down the area one more time just to make sure any residues removed, any dust is out of the way. Again, the area is completely clear. Okay, so now for the next step of our experiment, we are going to pour our copper gluconate into a 250 milliliter glass beaker. Okay, so we're just going to quickly, and the way that I like to do it in terms of transferring solids is I like to pinch both ends and then pour. And then if you want to get all of the solid out, you simply tap. Simply tap on your weigh boat. There we go. And we'll leave our weigh boat off to the side, and we have our 1.4 grams of copper gluconate all ready to go. Next, we're going to take a 10 milliliter graduated cylinder, and we're going to fill it with our 0.5% sodium chloride. This should be in your lab box kit. Again, you're going to carefully pour. Make sure that you keep the cap secure and in your hand. And you're going to carefully pour. And it's better to under versus overshoot. There we go. So we're about at the 10 line. Just needs to be approximately 10 milliliters of the 5% sodium chloride. And now what we're going to do is we are going to pour this 10 milliliters of 0.5% sodium chloride into our copper gluconate solution. Now, what we're going to do is we're going to gently swirl this solution. To get as much of the copper gluconate to dissolve as possible. So we're going to continue to stir our copper gluconate solution. Not all of the solid will dissolve, but most of the solid should dissolve. And you should see this beautiful green solution. How's everyone doing? Does everyone see that green solution? When you're working along with your own lab kit, did you also get this green solution? Everyone doing okay with it? Okay, so now that we have our green copper gluconate solution, we're going to set up our ring stand in a well-ventilated, clean area on a heat-insulated level surface. I used a towel for heat insulation. You don't want to use the absorbent pad to minimize flammability issues. I just didn't want my table to have any risk. It should be pretty flame resistant, but you don't want there to be any risk associated with, especially if you're using, you just don't want to make sure that your surface is flame resistant, and you want some insulation just to minimize any risk. Okay, so next what you're going to do is you're going to set up your ring stand. And so to talk a little bit about the ring stand that we're using, let me move this out of the way. So the ring stand that we're using is comprised of three major pieces: the base, the long clamp holder, and then our ring clamp shown here. All of these should be put together from your lab kit, and you want to make sure that this bottom portion of your ring stand, this bottom clamp holder, is completely twisted to the right and secure. It should not move substantially. It should be very secure, okay? You don't want it moving around when you have liquids on top. Likewise, you want to make sure your ring stand is firmly clamped. So you give it multiple twists, and you want to make sure that it's stable. Okay, so just give it a few shakes and just check to make sure that it's stable. So here is a sample ring stand setup. Note that for this experiment, we are using a ruler and just making sure that our ring is approximately 8 inches above the base. So we're going to move this up just a little bit. Again, make sure the clamp is fully twisted and completely secure. Okay, so we have our completely secure ring stand. We have our solution of copper gluconate. And now what we're going to do is we are going to place the copper gluconate onto our ring stand. Allow me 1 second to find a boost so that way the camera can show during this heating process. Okay, so here's our complete ring stand setup. So we have our copper gluconate solution found on our ring stand. Our ring stand is secure on a level insulated surface. We have the area completely free of any other flammable containers or objects. Move this a little bit forward. Okay, so now what we're going to do is we're going to set up our sterno heating plate. So what we're going to do is we're going to look through our sterno heating plate. We're going to remove the cap. And then we're going to light with our match provided in the lab kit. So here is the top of our sterno heating kit, and we're going to open it using our spatula. But before we do that, we need to take off our gloves. And when handling hot materials, you want to minimize using gloves. One moment, apologies for the image delay. Okay, here we go. So here's our sterno heater. So we're going to use our spatula to pry open the top. And let's pause and we'll resume once we have the sterno heating cap open and we're ready to begin heating. Okay, so we're going to place our sterno can on our stand, and then we can light with the matches provided in the lab box kit. So we don't even have to use our spatula to open it, as it's a wick fuel. Depending on the brand of sterno container in your lab kit, there may be a slightly different opening and lighting procedure. Okay, so what we're going to do is we're going to light our sterno wick, making sure that our match is completely out in this process. Okay, now we're going to store the match, put our matches away, and we're going to continue the heating process. So, first and foremost, now that we have lit our sterno contents, the flame will light up immediately. Now, what we're going to do is we're going to place our aluminum washers. So the aluminum washers that we carefully set aside in our container, we are going to place them carefully into our beaker. So we're going to drop them in to our beaker. Okay, this will initiate a chemical reaction in which the copper will be reduced to copper 0 and the aluminum will be oxidized. The aluminum cup had our aluminum washers. So if you look closely inside our setup, we have our aluminum washers. We have our sterno flame that's applying heat. Let's move it over just before it gets started. and we have our beaker. Now, once it's going, you're not to touch the sterno cup at all during this procedure, nor are you to touch the beaker except at the top after you've extinguished the flame with a towel. That is why we have handy and sitting ready to go for this experiment a towel that I'm going to use to grab the top of my beaker at the end. So again, you're going to keep this entire setup away from any open flames or other flammable objects. Your sterno flame should now be leveling out. It should be a nice blue flame. It may not always be visible. I have pretty bright lights, so it's easy to see. And what you'll notice, and we're already beginning to see it. Does everyone notice the bubbles that are starting to appear? Does everyone see the bubbles that are starting to appear? That is a sign of a redox reaction. The aluminum is reacting with the copper in solution to make solid copper. That's why you're starting to see this like brown copper color appear. This is a classic redox reaction. The bubbles, in fact, are the result of a little bit of side reaction where we're making a little bit of hydrogen gas. Now, just to note, in terms of materials that I have handy, I have the cap always handy and ready to go. If the flame ever gets out of hand, you're going to use your forceps. You're going to use your forceps to put the cap back on, okay? Do not blow out this flame or you can spread a fire. Okay, so we're gonna let this reaction go for a few minutes. And let's look ahead to see where we're going with this. Let's go ahead and let's look at our next steps. Okay, so we're gonna time how long it takes for the solution to become completely clear. You should notice a pretty dramatic color change. So we're going to keep heating and observing this solution. And we're going to avoid heating for more than 20 minutes. So we'll heat until at least 238. So that's our cutoff. 238 is our cutoff. So we're just going to let this go for another 18 minutes. And during this time, what you can do is you can get your other materials ready to go for the subsequent steps. So, in terms of subsequent steps that you're going to need to have prepared, you're going to need to get out your 50 ml beaker. This will just hold waste from this experiment, just any extra water that we have. And this is where we're going to place any rinsing, etc. We're also going to need another beaker that we'll use to carefully rinse our washers. We're going to need our aluminum cup that we haven't weighed the mass of just yet. So don't worry. If we need to take a mass measurement, we'll talk about that. And then we'll talk a little bit about how to dry our copper using the baking pan. In the meantime, you can also take this time to wipe down your area, rinse off any materials that you have. So I'm just gonna remove some and wipe off the oily residue from my spatula from when I opened up the sterno container. And we'll let this continue heating, and if there are any questions, now would be a time to ask. And let's take a look. We're actually seeing something really cool. So, does everyone see how one of the washers is really disappearing now. Does everyone see how one of the washers is really disappearing? Yep, it's reacting. This reaction often requires a solution to reach a target temperature before it really gets going. And again, in terms of materials that we'll prepare, we want 2 beakers. We want to have our cup ready to go. We want to have our forceps ready to go. And we want to have some deionized water ready to go. Yep, the darker one is reacting. Yep. This reaction's buzzing along quite well. And we actually see that our second washer is slowly being reacted, and you can see substantial amounts of copper generated. Allow me one moment. I'm going to rinse off my hands briefly. And remember, do not heat for more than 20 minutes. So we have about 15 minutes remaining from the heating, or until we see the solution turn clear. Additionally, if anything looks like it's getting out of hand, make sure to get your forceps and use your forceps to put the cap on. Do not blow out the flame. I repeat, do not blow out the flame. So just to check in, for those following along with me at home using their lab box kits, how's everyone doing so far? Is everything going okay? Everything good?
Yes.
Okay, perfect. Silence is worrying whenever students are working with burners, so I always want to check up on everyone, make sure they're okay. I personally have a fire extinguisher in my house for shop work, so I have that ready to go, and it's a carbon dioxide fire extinguisher, so it's perfect for this in the event something does happen. Okay, so the reaction's continuing on, and if there are any questions, don't be shy at all to ask. We've only taken one measurement so far. This lab is very measurement light. You just measure the mass of copper gluconate that you start with, and then at the end of this experiment, we record the mass of copper that we've isolated. And from that, we can figure out the formula of copper gluconate and the percentage of oxygen in copper gluconate. So just to check in on our experiment, as you can see now, both of our aluminum washers have a substantial brown hue as a result of the generation of copper solid. You may notice the solution is also turning less green. The copper ions are the principal source of the green color in this experiment. And as a result, the copper ions, as they react, the solution will become less and less colored and will slowly turn colorless once the copper has completely reacted. So we'll continue heating for about another 13 minutes at maximum. And at this time, I just want to remember to continue watching your setup. Continue watching your setup. And once it's done heating, we'll continue processing our sample. Everything going okay? Remember, never reach above a lit flame, never reach around a lit flame, and never touch your sterno container while it is heating. It is very hot right now. It's quite a fun experiment. Sterno heaters are commonly used in camping, so it's a wonderful alternative to a Bunsen burner for these kinds of lab box at-home chemistry. And if there are any questions, now you may notice as well, this is really bubbling now. It's not boiling. This is from the reaction, and we clearly see the evidence of a chemical reaction on the surface of each of our aluminum washers. We don't have to worry about the mass of aluminum. It is used in excess in this experiment. And the washers serve a twofold purpose. Both they serve as a copper capture mechanism. The copper will stick to the aluminum surface as it's generated. And it serves as our reducing agent. So it's quite a cleverly designed setup. And this type of lab has been run hundreds of thousands of times in in-person labs. And this is a classic example of a redox reaction. Just to check in one more time, is everything going okay? Is the flame managing itself, and is the solution looking pretty similar to where I'm at in my stage of the experiment? For those following along, is everything looking okay? Good, good. I find the procedure makes much more sense when you're following along and seeing how it looks in the recording. Remember, just to keep an eye on the time, we can't heat for no more than 9 additional minutes. So we'll let it continue going for about 8 to 9 additional minutes until we observe a color change in our solution. We may not observe a full color change, but we want to collect as much of the copper as possible.
Hi, Professor.
Yes. Mm-hmm.
For the 50 milliliter waste beaker, is that plastic or glass?
It can be either plastic or glass. Whichever one you choose to use would be okay.
Okay, thank you.
As long as you clearly indicate it as waste, you're more than okay.
Okay.
Mm-hmm. In most chem labs, you have to wait for chemical reactions to take their course. It's good practice for when we move back to in-person labs. But overall, this is going quite well. We have our nice deposits of copper. Everything is occurring safely with no major issues. And we have about 7 more minutes until we're done heating and until we can snuff out the flame. Remember, do not blow out the flame. You smother the flame with the cap for your sterno container, and you have to let the sterno container completely cool before touching it. So you want to just leave it off to the side, let the entire setup cool. You don't want to burn yourself unnecessarily.
Hi, Professor.
Yep.
Since we're just waiting, would you like to see mine?
What was that?
Would you like to see my beaker?
Sure, sure. Let me open up the view. Yep, and you're more than welcome to share your view. Yep. And remember, while you're handling hot glassware, that your gloves should not be on.
Okay, hold on a second.
Yep, no problem at all. Yep, looks good. Yep, looks perfect. Yep, there are no issues I can see so far. Looks good. Perfect. I'm glad everything's going well so far. We have about 5 more minutes until we begin to process our samples. We have about 2 minutes until we're going to cut the flame. Let's just take a look at our solution now, and as you can see, we've undergone a pretty dramatic chemical reaction. Now, as it's approaching the 1 minute mark, what we're going to do is we're going to extinguish the flame by taking our forceps, holding the cap with our forceps, and then bringing the cap above the flame. Like so. We are smothering the flame of its oxygen source. You're going to leave the sterno cap on its own, and you're going to let it cool. The cans have a temperature indicator. It's very hard to see on this one. So we're just going to let it cool and leave it all the way until the end of the experiment. Let's be conservative and let's leave around 30 minutes to an hour of time for the whole setup to cool down. Now, and this is important. This is why I had you get another towel, is because this beaker is hot. You do not want to put hot glassware on a cold surface. So what we're going to do is we're going to use our towel and we're going to grab the top of our beaker. So the top of our beaker is the coolest part of our beaker. So we're going to use our towel to grab the top of our beaker and we're going to place it on our insulated surface. So I'm grabbing, it's a little awkward with the home towel. Allow me one moment. I'm going to get out an oven mitt to make this a little easier. Okay, so let's continue. So we're going to take our oven mitt and we're going to grab the top of our beaker, and we're going to place the beaker down on our insulated surface. We're going to allow our beaker to cool, and we're then going to discuss how to process our solution. So at this stage, we're going to need our 2 beakers and our aluminum cup, our scale, our deionized water. So one of our beakers will be waste, the other will be for rinses, and then we'll have our aluminum cup. We'll also need our forceps and our stirring rod. While we're waiting for our sample to cool, we're going to pour 30 milliliters of deionized distilled water into our graduated cylinder. And then we're going to pour it into one of our beakers. That'll be our rinse beaker. Now we're going to wait a few minutes for our beaker to cool, and then we'll resume our processing. So at this time, now that everything has cooled, you're welcome to resume placing your gloves on. Okay, and now we're going to take our beaker, which should be relatively cool now, and we're going to pour the liquid contents into our waste container. So this will be our waste container, and we're going to carefully pour the liquid contents. So now all we have left are 2 aluminum pieces covered in copper. So now what we're going to do is we're going to take our aluminum pieces, we're going to grab them with our forceps, and then we're going to dip them. We're going to dip them into our and immerse them into our deionized water. This is just a rinse. Now, before we finish processing these, we're going to weigh out our aluminum cup that we're going to use to dry our copper. So here's our balance. Our balance is set at 0, 0. It's zeroed out. Now we're going to place our aluminum pan on the balance, and we're going to record the mass of our empty aluminum pan in grams. So this gives us a mass of 2.3 grams for our empty aluminum cup. Does that make sense to everyone so far? Does that make sense to everyone? Everything going okay? Okay, so continuing on with this process, So continuing on with this process, we're now going to, yes, 2.3 grams, or in this case, 2.4 grams after it finally settled down. Okay, so we recorded the mass of our empty aluminum cup. So now we're going to set both of these to the side. So now we have our aluminum cup and we have our aluminum pieces coated in copper. So now what we're going to do after dipping our piece in deionized water and rinsing our piece in deionized water, we're going to place the piece down into our aluminum cup. Just only one at a time. Okay. Now, what we're going to do, and this is a little bit tricky, with one of our pieces, what we're going to do is we're going to pin it down with our stirring rod, and we're going to use our forceps to scrape the copper off. Sometimes these things just fall apart, but we're going to scrape the copper off as much as we can. Just do as best of a job as you can. It should fall off. Should be almost smooth as butter. If it's fully reacted, the copper should fall off pretty quickly. And make sure to get the inner ring as well. Okay, we've almost scraped off all of our copper. Just make sure to turn it around and really get off all the copper. Okay, so this is pretty clean now. So let's repeat for our second piece. And if it falls apart, make sure to grab any of the copper pieces that end up in your other container. Okay, so now let's take our second aluminum ring and let's scrape the copper off of that too. You want to get as much of it as possible for an accurate result, but it's home chemistry and this is not a quantitative transfer method. So you just want it to be as perfect as you can get it. Okay, so we've cleaned off the majority of our copper from our aluminum pieces. Notice how they're much more silvery now. And now we have what is supposedly leftover copper in our aluminum container. Now, all we have to do is dry our copper as thoroughly as possible. And to do this, we're going to put it in the oven. Now, if you don't want to put your copper sample into the oven, an alternative is to allow this sample to air dry in a secure, well-ventilated area, such as where you're performing your experiments, for about 1 to 2 days until it's completely dry. I'll be showcasing the oven method. So I'll be setting it up on a baking pan and putting it in the oven for the desired amount of time. In this case, based on your laboratory manual, you're going to want to heat it for about 15 minutes or until all the water is evaporated. So I'm going to put this in my oven on a pre-prepared baking pan. So we'll pause at this time and we'll resume once it is finished baking. Okay, so we finished completely drying our copper in the oven. Here is what our dried copper looks like. Now, what we're going to do is we are going to carefully transfer our dried copper onto a tiered balance containing a weigh boat. So we're going to place the weigh boat. Here we go. Then we're going to tare our weigh boat by pushing the tare button. Okay, so with the weigh boat on, it should read 0.0. Now, what we're going to do is we're going to use our spatula and we are going to transfer the contents of our aluminum container to the weigh boat. But before we completely do that, as an external check, we're going to record the mass of our copper plus our aluminum weigh boat. So let's record the mass of our copper plus our aluminum weigh boat before we transfer it. So here's the mass of the copper and the aluminum cup before transferring. Now, what we're going to do is we're going to take a tared weigh boat and we're going to transfer our solid copper to the weigh boat so that way we can take a little picture. While we're here, we might as well take another mass measurement just for completeness. So let's scrape our copper. We actually made a fair amount of it. It's good. And it should be bone dry if you've done everything correctly up to this point. If your oven got a little bit too hot, you may get some copper oxide. Let's try some things just to get it to register. So the balance is having a little bit of trouble picking up, so we can't just weigh it directly onto our balance, but just as a final portion of this exercise, just for the picture you'll be submitting, here is the copper in the weigh boat, and you're going to submit a picture of the copper in the weigh boat as part of your lab report. And that concludes today's experiment for the determination of the formula of copper gluconate. We'll then move on to discuss the laboratory calculations, and we'll clean up this experiment. So we'll pause this experiment portion at this time. And once you've reached this step, you're free to begin cleaning up your experiment. For the weight, looking at the recording, would someone from the class like to provide a measurement that they took for the mass of the aluminum plate and the copper? Would someone from the class like to provide a measurement? Oh, for the copper itself, the balance couldn't detect it. It's not accurate enough to detect the mass. I can try recalibrating it, but it's not picking it up. So the putting it on the weigh boat is just to check. It's just to check the, and just to take the photo of the copper. For the mass of the aluminum and copper, it was found to be 2.6 grams, and you can double check that in the recording. Any other questions I can address? If not, we'll close out this experiment session. We'll clean up, and then we'll discuss the laboratory calculations. The copper gluconate was 1.4 grams starting of copper gluconate.